I'll take the first 5 minutes and then you can go ahead.
You want me to wait 5 minutes more?
No, I'll go to the first 5 minutes. Let me start the first 5 minutes. Okay,
I
so
Yeah.
yeah. So again, thank you for joining. Just a quick recap. Last week we talked about Git. So I showed you how to create an account with Git. Download Git, make an account with GitHub. And we also talked about cloning, pulling, pushing code, and also forking. Um, also, oh, just give me 1 second. There's one thing that I missed out that you can also do. It's make it it's okay, let me share my screen. So if you, this is my personal one. So if you go to settings, you can also create SSH keys here. And you just, here it's a guide on generating. I'm not going to go in details right now, how to generate a new one and everything. So and then you just click new and follow, you can follow the steps as well. Before I hand over to Kapil with the talker, also there's lots of videos on my channel that talks about coding and Python and the EC2, AWS and everything. So I'll also share this in the chat, so you can go ahead and subscribe, and then even there's lots of video I put here up here as well. So I'm going to hand it over to Kapil for to take over for talker. Elizabeth, do you have a question?
Okay, shall we start?
Yeah, I don't.
Okay.
Go ahead.
So hi, Ashfaq, Greg, and Elizabeth, and Mickey. First of all, I just want to share something I know in Docker with you. And second, I want this session to be a participating session. Like I don't want to be a lecturer and enforce my knowledge on you whether you understand or not understand. This is basically a hands-on session. Hands means uh, I wish if whatever I give you, you really take it and you understand that. If you have any doubt at any time, you please ask. Uh, for like Greg and Elizabeth, I know the other two people. Oh, okay, Partha has also joined. So let us all share one line about ourselves so that we can introduce. Hi, my name is Kapil, and I'm from IT operations, and I'm presenting Docker today. Hi, Ashfaq, please tell me something.
Yeah, hi everybody. I'm here to learn all the new technologies, whether it's GitHub, whether it's Docker, and oncoming sessions. So just to enhance my skills on the software development side. And last week's session by Mickey was really very interesting and very helpful.
Mhm.
And I'm sure I'll be getting the same knowledge from the others also as well.
Thank you. Hi, Partha. Please share one line about yourself so that others can know you.
Yeah, hi, I'm Partha. I'm a DevOps engineer, and I've been in the IT business for 20 plus years. I'm here to learn as well as to share my knowledge. I don't don't think that I don't learn. I also learn. It's IT is such a business that on a daily basis there are new things coming up. Today I learned something called what is the name of that stuff?
Docker.
No, okay. Today we are learning Docker, but something new that I learned that there's a platform called Mendix, and that's they call it low code development platform where everything is composed rather than code is written. So that's something new I have to learn. So that's it about me.
Okay, I think one person accidentally dropped. Mickey, can you please ping that person? I think Elizabeth. Uh,
She
okay,
was she said she was driving, so maybe
okay,
she
no
dropped
problem.
off
You
that.
can just
Yeah.
message her if you can, please just message her. If she wants, she can join back, no problem. Greg, would you like to share a line about you? Just a minute.
Hi everyone, can you hear me?
Yes.
Yeah.
Okay, awesome. So my name is Greg. I work as a senior BI developer with Pressima. So for me, I'm the team leader of one of our projects Kala is working on. We call ourselves the future. I know this. Ash is my team. Elizabeth is my team. Saga couldn't make it today. She's also my co-team lead. So we're trying to learn all these new technologies to help us get our projects up and running. Some of these things I know, like I use Git, but I'm always open to learn new things, and learning these new technologies will help me also improve my skills towards the software development side. That is what I am here to do, just to learn. Thank you.
Thank you, and I hope everyone knows Mickey. Mickey, would you like to say one line about you?
Sure. So everyone knows me, but yeah, just my name's Mickey. I work with Shout and Carter and Testoper, and usually I just working on coding. I'm usually a freelancer, so if I get projects, I work on that. And yeah, that's pretty much it for me.
Thank you, Mickey. In last session, I Elizabeth joined. Hi, Elizabeth. Can you share a one line about you? We all shared. No problem. I think she's still driving. So in the last session, we learned about version control system. I shared my slide, whatever I like presented last time. If anybody has any doubt or like anything, they can message me or Partha. Partha is of course an expert, and I'll try to answer the question if possible on Git. And it's more like we whatever we did was all theoretical last time, but more doubts and more experience will come when you will have some hands-on on that material. And that was the foundation material. It's very advanced when you practice it and do it. Okay, so starting with Git, let me present my slide. Uh, okay, here. Okay, is my screen visible to you?
Yeah, it's visible.
Yes.
Thank you. So I'll I see because it's 6:20, so I'll try to finish the session by 7 o'clock, else by 7:15. So in like first of all, let me know, is there any commitment anyone has by 7, or can we take it to 7:15 if required, not mandatory?
Yeah, I have a commitment.
Okay, so we'll
Um,
try to finish by 7 in that case, no
yeah,
problem.
and Cooper,
Uh,
you also have next session with
yeah.
Docker.
Yeah, so in today's session, I'll be just discussing about the basics because I just yesterday I shared the steps and somebody was having a problem. I don't like in team somebody commented that he has a virtual box and he's having problem like implementing the whatever it was written as an instructional step. So uh, we will reply to you. Me or Partha will reply to you on that particular thread. And what is Docker? Like, is anyone who does not have any idea on Docker? Basically, because everyone is aware about Docker. Is anyone who is not at all aware? So I will
No,
take
I
it
don't
that
know
way.
what is Docker.
Yeah.
I
Kapil,
don't know
that's
what is Docker.
new to me.
Okay, new to you. So let me let I'll take everything very rapidly, and I'll try to explain. And if anything is left, we can cover it in next session, or you can always call ping back, right, on the messenger or anything. So introduction to Docker. What is Docker? Basically, when a Docker is, you can see a fish and there are a lot of things over the fish. Basically, Docker was the concept taken from is a similar to shipping industry. When we when you courier something from Malaysia to China or any country to any other company, it goes through phases. Your whatever you do, whatever you send as a courier is combined with other items and boxed into a single container, and then that container is like uh, built into this. You can see this gray kind of two boxes here. So everything is packed and containerized, and this is how Docker concept of Docker was born. So you may also have seen the big trucks that go in the road, and we call them as cargo or whatever, because there is truck is like a single container, and in that single container we put all our parcels and they are delivered then. First, like they go to a ship and the ship travel between two countries, and from there again it goes to different trucks, and again it's parcel to your home. So this the same concept was taken, and let's see. So for example, what is Docker, what is not Docker, what are basic, you can see the four sections. This is I'm going to cover in this slides, and I'll not be covering section 3 right now. Uh, so what is Docker and what Docker is not? So let's go to the next slide. Okay, so first of all, there are two applications in computing world, and one is like a monolithic architecture and other is a microservice architecture. There is a difference between two. Monolithic architecture is something like an old transistor or a radio in which all the parts are combined and coupled together and they work as a single unit. If one part is faulty, the radio will stop functioning. There will be no noise, no music, nothing. But in the microservice architecture, it is designed as such, even if a part will fail, the same part will be regenerated and all the parts will function as an independent unit. Uh, this is something like it's not I'm not able to present very well in that image, but what I'm talking is, uh, Partha, would you like to comment something here? Hello?
Yeah, yeah. Hold on.
Okay. Okay. In case you are occupied, it's okay. I'll carry on.
Muted again. My computer is muting me for some reason. So anyway,
Okay.
yeah, containerization is if you take an application like suppose you have Windows and you have Word running on Windows. Whenever you want to install Word or Office on Windows, you have to install an application and it gets tightly coupled with the operating system. Now, if you want to install something that runs on Linux, you cannot install it on a Windows computer because the operating system does not permit it. How can you run something that is Linux on a Windows machine, or vice versa? How can you run Windows on a Linux machine? So somebody spoke about VirtualBox right now. So that is what basically a container is. A container is um uh, a package that can be run any place, anywhere, and it is contains all that it needs to run. It relies upon the underlying operating system for certain services, but everything else that it needs, it has in itself. So if you take a car, for instance, You can buy a tire for a car from any place as long as it is matches the. Suppose you have a 5-bolt tire, five bolt hub. You need to buy a 5-bolt tire. As long as you have the size of the tire and the width and the radius and diameter, everything okay. You can put any brand tire onto any particular car as long as you match these things. So exactly like that, a container is something that is packaged as an application in such a way that it can be run in any place with certain provisos, of course. So that's a container. Now, why did they get this shipping thing into it? Well, the a shipper does not need to know what is inside the container. All the shipper needs to know is the container the right size for the type of ship I'm having and the type of holes I'm having. This is my standard size of container. Or all the containers the same size, I can stack them well. I can stack them, I can tie them down, I can ship them, and then what the other end will do with the container, the shipper is not bothered. And the shipper is not bothered with what inside the container. Exactly the same as the application is packaged into a container. The person who is going to deploy it doesn't have to even bother about what is inside it, as long as he knows that the container does this, and I have a system that can support a container running a container. That's all that is required. So one of the most common container technologies is Docker. It's not the only one. You got Docker, you got Container D, you got LXC, which is Linux container. You got Zen systems, which is another Linux variant. And of course, you got virtual server from Windows, which is a virtual server, which is a Windows container system, and so on. So VirtualBox is another one.
And
Uh,
this like monolithic and a microservice architecture. This is the point I want you to please help me with.
yeah, monolithic and microservices, like the it's a whole long evolution of computer technology or application technology, basically. If you take something like um, let's take a washing machine. The washing machine has a program running inside it. And you select some things externally, and then it runs. Suppose your washing machine, the spinning thing gets bad, you can't do anything. You have to completely replace the whole internal or your treadmill. If you have a treadmill machine that you're running, if something goes bad with the control system there, you have to toss out the whole board and put a completely new board inside there, which has all the controls. Whereas if you look at Mr. Terminator, the Terminator, even though his arm was cut off and just the hand is, separated from the whole body, the hand still crawls along and tries to do the job of killing whoever the Terminator was supposed to kill. So that's what a microservice architecture is, that each independent component works on by itself. It does get messages from other components, but the whole system is not dependent upon one single component. If one component fails, the other components can still work, but with reduced functionality. If everything else fails and only one component is alive, even that one component will continue to the job that it was supposed to do. It does without anything that it depends upon for other components, it will not work. But whatever it depends on for in itself, it will work. So that is the whole concept of making each individual function within a large application independent of each other. So like if you take a banking application, you've got multiple things like, okay, I have account, I have credit card, I have my basic savings account, I have a credit card, I have points that I collect from credit cards. Each one of these can be separate applications. They do
Uh,
depend upon the client ID and the card ID for individual, but these can be separate. So that's the difference between having an application that is so combined that you cannot separate the components out, and having multiple components that act and work independently, but do work together also.
Thank you, Partha. Uh, like Ashfaq, Elizabeth, and the other person, I've got Greg, right? Do you have
Yep.
any concerns? Because I don't want I don't want to speak to walls. I want your participation so that I understand I can proceed or not. Is that okay?
Yeah, Kapil, yeah, concepts were very clear.
Thank you, thank you. Okay, let's move. So rest of the presentation I'll be taking up very rapidly because I don't want to get into theory. I want to come to practical. So what is Docker and what is Docker file and what are basic Docker commands? So this is something like Docker. So let's read what is on the right side. Standardized packaging for software and dependencies. So earlier, if as Partha said, if we want to use MS Word, we have to install all the uh, dependencies of MS Word, and that comes in a setup file, and you run the setup file in your Windows operating system. The MS Word is installed, and then you can use it. So in a similar fashion, for example, if to install a particular application, you need at least 500 GB of 500 MB of RAM. But when that application actually runs, it does not that 500 MB is not into picture. It hardly takes 5 MB, and rest of 495 MB or majority of chunk of that application is not used. So basically, container is a standardized packaging for software and dependencies. We make that container spin or run only with the amount of memory that it needs, so that we can run multiple containers at the same time and isolate applications from each other. How this containerization was born? This containerization is not a new concept. If you have studied Linux, you may know that Linux has different threads on which programs run. From there, the concept of containerization eventually evolved from Linux, and they share the same operating system kernel, works for all major Linux distribution, and native to Windows Server 2011. If you see on the left side, there are three containers, and these three containers are different dependency. Like first one has Tomcat, Java, Debian has an application which uses these three. Then second has some other application. Third has some other application, but ultimately they are running on a same kernel. And this is how Docker runs. So a role of images and containers. Basically, a container is an instance of an image, like in object-oriented programming, like C++ or Java. I'm just giving you a reference. There is a class and there is an object, but object is just a representation of class, and everything happens in the object. Similarly, I'm saying similarly, I'm not saying same. Just to give you a reference how it works, there is a Docker image in which everything is there. Like it can be 1 GB or it can be 500 MB or it can be 5 MB. And every instance of that image, when it runs and process something based on the same, like class and object, the same concept, and that is called a container. And whatever, for example, if I have a image called XYZ and I run three instances of it, means the same image is running three containers, and all the three containers have different data in them, though it is a reference from the same image. So this is something about like image and container. It will be more clarified. And Docker containers are not VMs. So some people have a very confusion like VMs and virtual machines and containers. Container are very minute and very small. So somebody talked about virtual box, and some people in the thread, and some people have the concept of hypervisor. They are completely different. They are basically partitioning your hardware into new different version, different pieces. But this is not what containers do. Containers are a representation of a image, and they run independently of each other. So easy connection to make fundamentally different architectures means as we saw, like there were three containers and all the three containers had different architecture in this last image. all the three containers have different programs. Similarly, they have different benefits, and this is something like Docker containers versus virtual machines. So if you see on the right side, there is a infrastructure machine. On that, there is a host operating system or a hypervisor. And on that, there are three different guest operating systems in the right side. In the left side, you see there is an infrastructure and there is a host operating system. And then there is a Docker runtime installed on that host operating system that can run as many containers as you want. So in the right side, we are partitioning a hypervisor or a hardware into three different operating system. One is running Linux, one is running for example Ubuntu, or one is running Red Hat, and one is running Windows. So more and more partitions you make, more and more memory the system will absorb, because to run every operating system needs at least 1 GB space to run, for example, like different for different application. But in case of left side, the blue image, you can see there is a Docker host operating system, and then there is a Docker runtime engine in light blue, and then there are application A, B, and C. There are three different containers, and you can run as many containers as you want simultaneously. And each container does not require 500 MB. It will require only 5 MB. The basic libraries or DLL, whatever it needs, it will take from like the Docker runtime or the host operating system. And if we see the colored full images, these are the same representation of these blue images, and the same concept is being shown. Like if you have two different guest operating system, green and orange, it will again divide the memory, use more resources. But the when you install host operating system in black and blue Docker engine, and then you can have as many containers as you want. Can we proceed?
Sure.
If anybody has anything to ask, please ask me right now.
Okay, I have a question.
Sure.
Yeah, I mentioned that I have a VirtualBox on my Windows machine, right? So now for Docker, okay, let me just go back a little bit. So the VirtualBox, I have Ubuntu
Mm-hmm.
installed in my VirtualBox, right? So with this, with Docker, can I uninstall my VirtualBox so that will I be able to run Ubuntu
Mm-hmm.
like a Docker image?
Yeah. So
Uh, See, fundamentally, Docker and on a Windows system, Docker and VirtualBox cannot coexist because they use completely different philosophies of how to use the base operating system and how to set up virtualization. So, if using Docker, you can set up a Ubuntu virtual system on your machine. Um but fundamentally you can have one or the other. You can have either VirtualBox or you can have Docker running. Both can provide you whatever virtualization you want.
and I
So
hope within the VirtualBox you can install another Docker. But on Windows, yeah, like this
no,
is something possible.
it is not possible. You cannot install it. It won't run because the networking will get completely messed up. You will not be able to do anything with that box. You cannot reach outside. You may be able to do some Linux commands in it, maybe. I don't believe
Uh,
you can
uh,
really do
I
networking.
no, yeah, net something, but some functionality can be done. I tried it before. In a VirtualBox, I tried to install Docker, but however, it was a command line interface. It was not an interface like we have in Windows. So, and I haven't used that much.
Yeah, I think I installed like you mentioned, command line interface. I was able to run some commands, so I don't have the GUI. I don't have the GUI, but command line works.
Okay.
Yeah, so you're having Docker running inside your VirtualBox Ubuntu machine.
Yeah.
And I don't know if you can actually reach the internet from your Docker instance, because there's three layers it has to go through before your network call can get out into the internet. So I don't know how that works. I haven't tried it anyway.
Okay.
So unless you have really very strong affinity for VirtualBox, or you have something very important that's running in your VirtualBox machine,
Yeah. Yeah.
then
I also have Hadoop there, so I don't want to delete it.
No
yeah.
problem. Let's move ahead. We have 20 minutes left. So, what is Docker? You can read it from the slides. I like take it very fast. Lightweight, simply building, shipping, running, runs natively on any operating system like Windows or Linux. Any of these two operating system, it works. Run on Macintosh also, and relies on images and containers. And using Docker big build, ship, run workflow. Like as you can see, there are some development. Like you can Partha, can you please explain this in a better way?
Yeah. Um, you see, when an organization, in an organization, a development team is developing something, they will be developing locally on their individual components will develop locally on their individual developers' machines, and then uh, the code will have to be built into something that can be run on a system. If you build it as a Docker image, the application or the application, the components of the application, each can be a different Docker image. If you have, let's say, 5 separate components and 5 Docker images can be built out of it. The 5 images can be transported and transported to whichever cloud system or external system that you want to install it on, and can be installed there and can be run from there, so that the application is made available to the external world for access and use. So this is very much simplified if you have an automated process that can take the code that the builders are, the developers are developing from the code repository that they have merged it into. Build the build process is automated. The build Docker images have been built, and then you can push it to a Docker registry. And from a remote system, you can pull the images from a Docker registry and actually install it and run it. Or if time permits, today we can actually demonstrate that, not the whole process, but at least the last part of it. And if not, next week we'll demonstrate that.
Okay, so basically we can build the Docker images and we can run it. So we can create images, store images, whatever. And next, there are some vocabulary like image, container, engine, and registry service. I'm not going through this because less time is very less. I've already talked about Docker image and Docker container. So, okay, let me do it. So what is Docker engine? Docker engine is basically that runs the Docker containers on any like physical machine, virtual machine, or any cloud or any data center. This is the something which drives Docker. Is Docker engine. You can check more after the presentation is gone over. I'll leave the slides and a registry service. So like Windows has Windows registry, similarly Docker also has Docker registry, but it's correlated, but it's not the same. Uh, and
No, let's not confuse the Windows registry with Docker
yeah,
registry.
yeah, I just said like there is a concept called registry, there is a concept called Docker registry, but they are completely different.
Docker registry, you can just think of it as a Docker repository. Okay.
Yeah. Okay. Uh,
Repository for images.
so these are some basic Docker commands. I will demonstrate these commands today if possible, and why we use these commands. To pull a image, the first command is used to list images in the Docker system. The second command is used to run a container. Like this third command is used. The fourth command is used to basically get the details of the container, running containers, and then stop the container and remove the container, the next two command. And if you have to remove a image, Docker image RMI, this is used. And then Docker push node, Docker help, uh, instructions on how to build a Docker image. These are some instruction like a screenshot and looks very similar to native command like we use in Linux or Macintosh. These look like that, but it's not like that. Um, and then the section 2 talks about anatomy of Docker container, which is Docker volume and Docker use cases. I'll not be covering that much because we don't have that much time. So, okay, Docker volumes. So this is very important. Volumes mount a directory on the host into the container at a specific location. Like in Linux system, you have to mount. Similarly, you have to mount volumes, mount a directory on the host into the container at a specific location. And these can be used to share data between specific containers, and can be created in a Docker file or command line interface. Why do we use containers, volumes? Because mount local source code into a running container. There's a container which is already running. You want to mount the source local source code or improve the performance. We use that. Number three is networking. Docker networking we will not be covering because this is an advanced concept. And then Docker Compose. What is Docker Compose? Compose is basically multi-container application. When you want to build a container and run one container at the same time, or you want to like make your own customized container, or customized kind of you want to run a customized kind of task, or manually connect containers together, you can use Docker Compose. In that case, basically it's writing a script. So this is about this. And then Docker Compose, I'm sorry, I'm taking it very fast because I want to do some practical also. Docker Compose multi-container applications. So this is just like, this is a file and this is a code between file. For each and every container, we write some scripts and which define whatever will be done in that particular container. And Docker Compose basically scale container application means, as I said, like you can customize your own containers and your own Docker images, and it just the script. As the script is run, it will be implemented on the flow. And let's leave it. And now I'm pulling up a second slide. Okay.
I just want to speak a minute or so before we go to the next concept. What is important, very important to understand is there are Docker container not only has an operating system, it also has an application inside it. And there are thousands of containers with applications already built and made available to available free of cost. So today, if I want to run, let's say I want to run MongoDB, or I want to run MySQL, or I want to run PostgreSQL, I can just pull a container and run it. It already has SQL. I don't have to install anything. I don't have to configure anything. It already has got PostgreSQL. I just run the container and start using my PostgreSQL. And once I decide that, okay, I'm done with it, I want to toss it away, I just toss it away. There is no uninstall. You just have to delete the image and it's gone. So your system is clean and back to what it was before you install the container. So the advantage of that, if I want to run a Jenkins system, I just pull a Jenkins Docker container and I have a Jenkins running on my local laptop and so on. So yeah, go ahead.
So I just want to show you, first of all, when you install Docker, you can implement it either by PowerShell or via command prompt. So for example, my Docker is running right now. And what can I do? I can, for example, I open a command prompt, right? So whatever I'll be mentioning in the slides, I will be implementing here so that I can show you. So if I want to show the running things in Docker, command is docker ps. It will tell you, okay, right now no container is running. So it does not show anything. The prerequisites I have already shared with you yesterday. This I hope the same are there in the slide. So let's uh,
Yeah,
you have to,
it's the same. It's the same. Go
yeah,
ahead.
yeah, it's the same. And then you have to find wait. For example, you have to find the version of Docker. This command gives you entire details on the version of Docker. And then docker ps all, like I just run docker ps. It gives you the details of container. All means all the containers, including the containers which are not running. So it's showing the details of container like which I made 8 months ago, 9 months ago. It's still in this system. Run the docker tutorial containerized app. Like I can run this command.
Make that port 80. Don't make it port 80. Make it port 3000.
Both the things.
No, only the first one.
Okay. So this means it's referring to port 3000 of the container.
No, no, the port 80 of the container, but
Okay.
3000 on your system.
I mean to say, yeah. So this is
Okay,
complete.
just 1 second before you go ahead. What is happening now? You're asking for a Docker to run a particular container, which is called Docker slash getting started. It does
Mhm.
not find it on your system, so it is going to the internet and fetching that Docker getting started because it is lying in Docker Hub. That image name that is given as Docker slash getting started means the registry is Docker registry and the image name is getting started. There is a minus D in the command, Docker run minus D. Minus D stands for detached.
Detached mode. Yeah.
Yeah, if you don't put a minus D, the terminal will be held up. The terminal will continue to just continue to reflect what is happening inside the container. The next you have the port. You got minus P stands for port. Which port? So inside the container, it is exposing port 80. So the application is accessible on HTTP port 80. Now you can choose to expose whichever port you want on your local operating system. You may have already another application that is running on port 80. So you may like to expose some other port. So that's why we changed the port to minus P 3080. So on your local system, you have to do HTTP to port 80. Okay, we
Yes.
can see that, Kapil.
Just one moment. So for example, if you want to really get started with the Docker, please follow the installation instructions I shared yesterday. That was shared by actually the creator is Partha. And then you can go here, localhost.tutorial.
No, don't go there.
It won't run.
No, no, it's localhost colon 3000.
Oh, yeah, sorry.
I don't think there's a tutorial required at the end. No, Kapil, the address is still wrong. Make it http://localhost:3000. Yeah.
Okay, so you have entire tutorial. Please go through this tutorial if you want to get started really with the Docker. And let's move next. So getting started tutorial, if you go into the dashboard, this kind of icon you will find. For example, if I go here and if I go here, there is similar icon here. And if I click here, it says like these kind of options I have. If I click on dashboard, it will open the dashboard of my Docker in a GUI mode. You can see it has all the images that I have on my system or I used to have, whatever. And like from the dashboard, you can start, stop, or delete Docker images, and you can continue tutorial. Like if you click on our application, if we go here, we click on our application, this will show, and you can download package.json from here, and you can follow the instructions. And continuing the tutorial, like you can
Yeah,
see
you have to go
yeah,
through the tutorial by following the slides. Kapil, can you point to the location where the slides are available
I will upload
in
to
Teams?
the in the Teams.
It is already there.
No, Mickey has like pointed a new location in I forgot. Mickey, can you tell please?
It's in copy. The photo will be the Testoper project general.
Yeah, Testoper projects. Yeah, in the Testoper projects file section, I have already created a folder and I will upload the slide there. So
You've got
yeah,
three slide decks for Docker.
yes,
So you need
yes,
to upload all the three, please.
sure. Including the introductory one which I shared, I will upload everything.
Yeah.
So then if you see eh, shall I skip this all because this will be confusing right now?
Yeah. This is something to be done step by step. It's not, you cannot, it's not a slide deck, informational slide deck. It is an actual hands-on tutorial, hands-on how to run the tutorial, and it has to be done either by somebody leading you or you yourself sitting and going through each step of it. Okay.
So there is the same command docker run -d -p 3000
No,
getting started.
this I
We just
think
did that. We just implemented this command and the second 3000 was 80 in our case.
yeah, 80. Not that is wrong. That is,
Yeah.
if you have the slide, you can even correct it.
Yeah. So like this is just modifying a app and replacing older image in this. So once we go through this, once we install this, we can demonstrate this. This is all for today. It's 7 o'clock. We are on time. 2 minutes left.
So, any questions at this stage? Okay.
I
I
want
mean,
to show everybody something, one more thing. Uh, Wait. This will give you the idea of what is DevOps doing today. This is a beautiful article I found on Partha's LinkedIn. You can see that, please. 1994, 90. I'm just quiet. So this is just 110 years of computing, and it started with mainframes and ended with the cloud computing right now, and we do not know the future, what it may be. Thank you. Uh, yes, please. If anybody has any questions or anything to ask, or any suggestions, what shall we do in the next session of Docker? Please come up.
Yeah, thank you so much for this. So I wanted to ask for the next session, are we going to do answer? I know today we kind of took it a little bit fast. Are we going to have real answer so that we can have a full understanding of it?
Um, I will discuss with Kapil and Mickey how to take this forward, because uh, if you people are interested in doing a little more hands-on work with this and get a little more elaboration and clarification on certain ideas, we can do Docker. We can continue with the same topic in the next class.
No, but like we had only 2 sessions of Docker. So rest in the next class, we have to do all the things. Practical theory is finished today.
Okay, so
You have 2 more
does
slides.
that
Yeah.
answer Greg's question?
Okay, thanks.
Okay.
And I'll also tag Bryce bought it. He's the new member I just saw.
Hello.
Hi.
Mm.
Would you like to share a line about you? Some introduction?
Yeah. Yeah. Okay. I'm Bryce Poutet,
Mm-hmm.
currently in Quebec since December 2020. I'm currently working as a um software validation engineer. Just started in April, and I in my beginning of IT in IT industry. So I have a mechanical engineering background. I
Thank you.
started with a coding bootcamp I took in University of Toronto last year.
Okay, nice to hear.
Yeah.
So, Partha will in the next session we will be taking on everything whatever we have in Docker.
Okay.
Like we will be practically implementing or doing through slides only, or shall we share all the 3 slides, all the 4 slides right now, so that these people can have a look and then we implement them like in the next session.
Yeah, I mean, please share the slides. Let the people who are attending, whoever can do as much of the slides as you can. We'll go over what you have done a little quickly, and then we'll do some demo of hands-on working of some of the things that we talked about. What is a Docker file? What is Docker Compose? How do you take Docker from a registry? How do you pull images from a registry and run it on a remote system? All that we'll do a practical demonstration.
Okay.
Great. Thank you so much.
Okay, I think we can close the session for today. Thanks everybody for attending.
Thank you, everybody.
Thank you very much for the.
Thanks everyone. Thanks Kapil.
All
Thanks
right.
Pastor. I'm Mickey
Right.
and everyone.
Welcome. Bye.
Thank you.
Bye.
Thank you, Kapil and Partha.
Thank you, Ashfaq, Mickey, everybody, Elizabeth, Greg, and Bryce. Thank you, everybody.
Have a good
Thank
night.
you. Hi,
Good
good
night.
night.
Good night.
Bye.
Bye.
Yes. Bye.